A very good evening to everyone. My name is Gaurav Kumar and I welcome you all for this webinar on web services. Okay, so we will be learning about web services, what is web service, how they work. A short introduction about myself. I'm a trainer and cybersecurity analyst at Network Intelligence India and Institute of Information Security. Uh, I'm a security researcher and I'm also a speaker at Null Mumbai. It's an open security community. It's all about spreading information security awareness. I'm passionate about cybersecurity and technology, and I have the willingness to gain knowledge about various technologies regarding security aspects and developing aspects also. My areas of interest are web application security, coding, system security, IoT, forensics, etc. And this is my Twitter handle and LinkedIn ID. You can contact me at any time. You can connect me with this. Okay, let's move. Okay, so today's agenda for web services are: what is web service, need of web service, characteristics of web service architecture, how web services work, components of web services, types of web services, securing web services, and we will be also being seeing some of the tools to test web services. Okay, let's start with the web service. Before starting with the topic, I want to tell, like, if I want to communicate with a person who understands and speak only Japanese language, but I don't know Japanese language, but I need to communicate with that person. So how would I communicate? Basically, I need a person who will translate both the conversation of between me and that person who knows both Japanese and English. So basically, I can say that web service does the work of a translator. Have you ever imagined like how websites communicate with other websites? Because websites are developed in different using different technologies. Like some are based on HTML, CSS, JavaScript, PHP. Some are based on Java and some on .NET and some on PHP framework. So how if a website developed on a PHP framework wants to communicate with the website developed on .NET framework? So how they will communicate, how they will share, how they will exchange data? So it all happens with the help of web service. The answer is you can enable web service to solve this problem. Basically, web service is nothing but one website communicating with another website. So web service is a service available over the web. It can be used for communication between two or different web applications. So communication is possible between the web applications only through web services. So there is a definition meaning of web service. A web service is a collection of open protocols and standards used for exchanging data between applications or systems. So it is basically collection and more protocols are used and standards are followed so that the data and information can be shared and exchanged between different web applications so that the smooth functioning of website can happen. There is a definition by W3C. Let me tell you about W3C. W3C stands for World Wide Web Consortium. It is basically a standard organization for the development of standards for the World Wide Web. So it gives the definition. A web service is a software system designed to support interoperable machine-to-machine interaction over a network. It has an interface described in a machine processable format, specifically known as WSDL. WSDL. We will be learning about what is WSDL in the later slides. So in the simple words, if I can more describe what is web service, so basically web service is any service that is available over the internet or private network for the purpose of communication or data exchange between applications. So it uses a standardized XML messaging system. XML stands for Extensible Markup Language. So this language has been used by web service to communicate between different web applications. And it is not tied or closely coupled with any one operating system or programming language. It is programming language independent, you can say that. And it is self-describing. It can be very easily described via a common XML grammar. Basically, the web services are mostly written on XML, and it can be accessed or discoverable by a simple find mechanism through UDDI. So we will be learning about UDDI in the later slides. So if I say we can also say that web service is basically an interface written in a machine processable format so that website can understand the communication and share information and resources with each other. Okay, so let's move to the next slide. I will tell you the working of a web service, how web services basically work. What is the working functionality that web services perform? So there's a diagram. Hotel A website, Hotel B website, Hotel C and Hotel D website are communicating with the xyz.com website. So basically xyz.com is a website which provides the details of the hotels and the room availability so that people can book rooms and stay. So if a user wants to book a room, so it will go to website xyz.com, and there he will get all the information about different hotels. So if a user going to xyz.com and it's seeing hotel A, and he is searching for a particular room, and while he's searching for a particular room, he found a particular room which is suitable for his date and all his work, so that he can manage to get that room. But while he was searching that room, he was going to finalize the room, another user has already booked that room. But uh, for the previous user, it is also showing, still now it's showing sorry, still it's showing that room is available. So when the previous user went to the final page of payment, it says sorry, no rooms are available. So there's a problem of updating the information on the website, which is xyz.com. So it affects the business, and it affects the mentality of the customer that this website doesn't work properly. Now it was showing like the room is vacant, and now it's showing no rooms are available. So it will cause a problem to the customer, and also affect the reputation and the profit of the business of that website, which is xyz.com. So what is the solution? The solution is like, if the websites of hotel A, hotel B, hotel C, hotel D are updating, so there's a particular amount of time at which they are updating the information. So there is a difference of time, like in seconds or minutes, which will cause a problem of updating the information. So web services come into role. The websites will use, all the websites which want to communicate with each other will use a web service to send the request and get the information in response to that request. And in this way, both the websites or many websites will communicate and share the information together, which will not affect the business and which will not hinder the customer, and it will enable the smooth communication and business operations. So let's move. So web services work on the basis of client server model. Let me tell you what is the client server model. In a client server model, there's a client computer. Basically, client is a computer which wants to access the service from the server computer. And the server computer is nothing but a computer which provides the services needed to the client computer. So client computer sends a request for information to the server, and the server sends a response to that request to the client. The medium is HTTP, which is over the internet, and the format is XML or JSON. JSON stands for JavaScript Object Notation. So it depends on the web service and its formats using the web services are using. So one website can communicate with another website using web services through client server model. The client sends a request and server sends a response. So why we need web services? Basically, these are the points why we need web services. First is basically so that many websites can communicate with each other. They can understand what other website is offering, what other website is doing, and a functionality, which services they are offering, at what price, at what time, and all other different factors. So first one is invoking existing function on a network. So what is invoking existing function on a network? Like web services allows you to like release or publish the functionality of existing code available over the network so that it can be used by other applications. Once it is exposed or released or published, so then it can be accessed by any other web application. We will take an example of a payment gateway. So payment gateway is an application which provides the functionality of doing the payment transaction. In most of the nowadays, everything is going digitalized. We are using more debit and credit cards, and we are doing payment online. So every website has tied up with some of the payment gateways, so that they redirect their users to that payment gateway, and though on the website of payment gateway, the users do the transaction and send the payment, so and it can get by the website. So there's a, you can take that as a function of payment gateway as an existing function which are used by different websites. Like it is possible many websites use the same payment gateway. Like one payment gateway can be used by different websites for bank, for restaurant, for hotels. So they are redirecting their users to the payment gateway websites. So it is using an existing function available over the network to use by different web applications with the help of web services. Second one is interoperability. As the name suggests, you can operate between different applications very easily. So it allows different applications to talk to each other and share data and services among themselves. Like other services can also use the web services. For example, a web application based on developed on Visual Basic or .NET application can talk to the website developed on Java and vice versa. So web services are used to make the web application platform and technology independent. So if there is a different platform or technology used by different web application, it will not hinder the working of the web application, and the web applications can easily communicate and exchange data between themselves. So it is used for smooth integration between two different applications. We can conclude that. The third one is standardized protocol. So there are different standard protocols used for the communication by web services. Like they use standardized industry standard protocol. They have some layers like service transport layer, XML messaging, service description, and service discovery. And it can also use well-defined protocols in the protocol stack. We will be learning about this standard roles and protocol stack in the later slides. I will be covering after this. And the fourth one, low cost communication. For enabling communication between two websites, you don't need to develop the website in the same, or web application in the same technology, so that the other we can communicate with that websites which are developed on those applications only. Like you don't need a high expensive, you don't need to do a lot of expense for the communication between different web applications, because the web services use SOAP over HTTP protocol. So protocol over HTTP protocol. So you can use your existing low-cost internet for enabling web services. You do not need any other thing. You just need your internet and some web services to communicate with other websites. And you can do with HTTP and FTP protocol. Let's move on characteristics of web services. Some web services have some characteristics like XML based, loosely typed, document exchange enabled. So as I already mentioned that web services use a common format which is XML, extensible markup language, is used for data representation and data transportation layers, so that it can be understood by different web applications at both the ends. The second is loosely typed. A web service interface or console can be changed at any time without affecting the working of the web application. So a tightly typed system or application means like the client and the server logic are similarly related to each other. The technology used by server should be used by the technology used by the another web application should be used by the requesting application. So it is not necessary. As I said, it's platform independent. So it can be easily integrated with different web applications using different web services depending upon your requirement. The last one, document exchange enabled. So web services support the exchange of documents to facilitate business integration. Ways of representing not only data but also complex documents. Like you can set a current phone number, like simple document, or it can be a complex register or book or collection of records. Let's move on and we'll see web service architecture. So basically the architecture of web service covers two things. First is web service roles, second web service protocol stack. So there are different roles in web service. Like first one is service provider, three major roles: service provider, service requester, service registry. The entity which wants to access the service will request for the service to the entity which provides the service. So the entity which is requesting or which wants to access the service is nothing but service requester, the service consumer, you can say. The service provider is the entity which provides the service. By service I mean web service, to the service requester, which is service provider, provides the service. And service registry is a centralized place from where the web services can be accessed by the service requester, and there had been put on or published at service registry by the service provider. So these roles play an important part in the web services. Like if there is no no service registry, basically you can say the service registry is a database or a repository where all the web services are put on. And if anybody wants to access those web services, he can just request, and you can the service registry and get the web service, and it can be used for communicating between different web applications. So if service provider has not built the web service or has not made the web service, so if anybody, service provider can basically make any web services related depending upon the requirement. For example, calculator or a currency converter or weather broadcasting like service, if you want to check which weather in which of the countries and what current rate of dollar is going on, US dollar and Australian dollar, etc. So suppose for example I want a web service which tells me the currency, about the currency rates, different currency rates. So service, some of anybody has published the currency converter type like name of the web service and has put on the service registry. So I'm a service request, I want to access those service for my web application. Like I use a web app, I have a web application and it requires the currency converter for smooth functioning of my payment and all those transactions. If I have the users of international users or some other users from abroad, so I will I will send a request to the service registry, and service registry will give me that web service, because already the service provider has published his web service to the service registry. So web service protocol stack, as I mentioned, like we will be covering later. So this is the web service protocol stack. It basically has four main layers. First is XML messaging. Second is service transport. Third is service description. Fourth is service discovery. So what is XML messaging? Basically XML, I already mentioned everything, and most of the web services is XML basically. SOAP uses the XML format, and many other types of web services use different formats also. So XML's extensible markup language format is used by web services to communicate communicate with different web applications. So a standard XML format is used, simple XML format. Like there are different tags in XML you can use, and you can write your own web services. Okay. Second one is service transport. Basically, this service transport layer is does the work of sending messages between applications. So this layer includes hypertext transfer protocol, simple mail transfer protocol, and file transfer protocol. And it can also use other different protocols as per the requirement. It just does the work of transporting messages from one end to another end, or basically responsible communicating. Third one is service description. As the name suggests, service description, basically describing a service. It basically, you can say that here the web service developer has described what the actual web service does. It's basically nothing. It's controlled and managed by WSDL, which is pronounced as WSDL. We will be covering later. So basically, you say that it is a description of the what the service does, what actually service is used for, what is the functionality of that service. It is described in service description. It is mentioned in the service description. And the fourth one is service discovery. As the name suggests, discovery, to discover or to find some service so that it can be used for different purposes and different requirements of communication or exchanging data between the web applications. So it is UDDI. I already mentioned UDDI. We will be covering it later, where all the, you can take this service description is the actual web service, which is WSDL, is basically the actual web service code, and service discovery is basically repository, which I said service registry, where all the web services are put on, and you can just access the web services from that particular place or centralized directory. So there are now move on to components of web services. There are two important components of web services: WSDL, which is pronounced as WSDL, and UDDI. So we will be learning about what is WSDL, what is UDDI. WSDL stands for Web Services Description Language. As the name suggests, Web Services Description Language, it describes what the web services does. So it is pronounced as WSDL. So it was basically developed jointly by Microsoft and IBM. It is the standard format for describing a web service. Like if somebody wants to develop a web service, so this is the format in which the web service develops. He has to write a WSDL, and it is a format. There are different formats, right? So WSDL is the language which is used by UDDI. So UDDI is a place I already mentioned, which contains different web services, nothing but WSDL. So it contains different WSDLs so that it can be used by service requester. So what does WSDL do? If I say in a small and simple terms, it describes three fundamental properties. What a service does, like what different operation methods, what is actually done by that web service, what is the functionality of that web service, whether calculating the amount or changing currency or showing the weather or just doing some mathematical operations or performing some different functions. How a service, second thing, how a service is accessed, like there is a particular service available, how it will be accessed, like what is the format, what different protocols it use, what does the requirement it needs to access those services. So basically it all tells the data format and protocol details. The third one is where a service is located. Now we have the service, we know what does that service do, how that service is accessed, but we also know from where that service is located, so that we can go at that place, we can fetch that information from there. So address or URL details of that particular web service or WSDL. Don't get confused in WSDL and web service. Basically, you can say that WSDL is a web service code, and UDDI is the place where all the web services are put on, so that it can be accessed by the service requester for their own purposes. And it has been published by the service provider. Like suppose there's a user A, and he has developed a particular web service, and so he has to describe that web service in the form of WSDL, and now he wants that his web service should be used by different web applications and different developers to communicate with different web applications. So he has to publish that particular WSDL or web service at some place, so that it can be fetched and accessed by different users or different web applications, and it can be used. So there's a particular repository which is UDDI, there he can publish his WSDL, and from there any requester or any web application which really want to use that particular service for their requirement and usage, they can get that. So the client sends a request to the server, and server sends the WSDL in response to the client. In this way the WSDL works. Like if you want a resource from internet, you just go and you just type in Google, and it sends a request to the server, and server sends you response, the resource in the response. Basically this thing, same thing. The UDDI which I was talking about stands for Universal Description Discovery Integration. Like we have a place where all the web services are kept on. So basically it's an XML based standard for description, releasing and searching web services. This is a place where all web services are published by different service providers. So it is a specification for a distributed registry. It's basically a registry of web services where you will find all different types of web services. It is platform independent. It uses WSDL to describe web services, as I already mentioned. UDDI is basically seen with SOAP and WSDL. We will be learning about SOAP in the later slides. Already we have discussed about WSDL. So this is like if I say a diagram about UDDI, so you can just imagine that there is a particular, you can say database or a central directory where all the different web WSDLs are published, one with the different usage. So I can get that WSDL, a particular WSDL for my own requirement from that particular UDDI. Yeah. Next, types of web services. The two types of web services we will be covering in today's session are SOAP and REST. We will be seeing one by one. What is SOAP? What is REST? How SOAP works? How REST works? Let's continue. Basically, SOAP stands for Simple Object Access Protocol. It's a protocol, is an XML-based protocol for sharing information between computers. It is used for communication between different web applications. It is a format for sending messages. It is used to communicate via internet. We need just internet to communicate. It's a platform independent, means there's no hard and fast rule that you should be using the same platform for using the SOAP if you are using the SOAP web service, SOAP type of web services. And it is language independent. It's easy and simple, and XML is the basically the general message format of SOAP. See, SOAP message, here's a client, which is service requester, the server, and the SOAP message. SOAP message contains envelope, header, and body. The envelope is the root element or the main element which contains the header and body. It is the first element in the SOAP message. The header contains the details of the message and includes the information like metadata of the message and other authentication information. And it is optional, it is not mandatory to include the header in the web service. The next one is body. As you all know, like if in HTML also there are tags and there are different heads and body, the body contains the actual data, and the same thing here, SOAP message contains so the body of the SOAP message contains the actual data. It has all the information which a web service needs. Okay. So basically SOAP web service looks like this. This is the format. I have already told you that envelope is the root element, is the first and main element. So see here, the SOAP envelope open. It is some written schemas.xml SOAP.org. It's a path, and it's using there's also a header present. I have already mentioned header is optional. Then the body tag open, and it has from currency. The question mark is the argument to be passed. This is basically a web service of currency converter web service, which is basically converting currency from one currency to different type of currencies. So from currency, like if I will say that from INR, which is Indian New Rupees, and to currency to like USD, so it will convert, and I will give the amount, and then it will give me the converted amount in US, how many US dollars. And again, then body tag closed, then envelope closed. This is basically how a web service looks. It's just a short example of how SOAP web services looks like. Now let's move on to REST. REST stands for Representational State Transfer. So it is different from SOAP. SOAP is like 20 years old, and now modern web applications use REST. This is more fast. We will be seeing the difference between the SOAP and the REST in the later slides. First, let me tell you what is REST. So it's a web services that communicates between two applications using the REST principles or rule are called REST web services. The rules are different from the SOAP. So in REST, each and every component is a resource, and all the resources are accessed by HTTP standards. So as I mentioned, like SOAP uses XML to make a request. REST uses a simple URL. Like if I go back, this all basically, if I want to use this particular currency converter web service, I want to write that much of lines of web service. But in case of REST, I will make a web service, and I will just give a URL. I have to just enter that URL, and can access that web service. It is faster than SOAP. So HTTP methods, as we all know, there are different HTTP methods: get, post, put, delete, trace, used by REST. Like get method is used to request a particular resource, and it retrieves the data. Post method is used to send data to the server. and it doesn't go in plain text in URL. It is going into the header request. The put method is used to basically upload a specified resource. The delete method is used to delete a particular resource or remove a particular resource. The trace method echoes the receive request so that the client computer can track the changes and additions have made by different intermediate servers in the path of the communication. Okay, so these HTTP methods, and there are other different various estimators like options, connect, which are also used depending upon the requirement of your task and work. So if I say REST includes a uniform interface, which includes a URI, resource, HTTP. As I already said, it has HTTP, and it is used by, it is accessed by URL, and every component in REST is basically a resource, and it is accessed by HTTP methods or standards, I can say. The second thing is stateless. Stateless means there's no hard and fast rule that it should state the data on the server. There's no need of storing data on the server. And by cacheable, I mean say cache memory, like the data is, if the server wants that the client's computer should maintain the cache memory so that the information can be accessed at later time in a fast and really improving manner, then we can the server can label the particular data as cacheable or non-cacheable in the server's response header, so that caching happen at the client side. And if again the client wants to access a particular resource, it should not send a same and again request for the same amount, same kind of resource to the server and get the response. It will be very affecting the it will just waste the time, and if caching has happened at the client side, it can be fetched from the caching header by the client computer. So basically REST relies on uniform interface. You can use URL, and it access everything from a, it takes everything, each and every component in REST is just like a resource, everything. Like if I want to access a particular employee details, so it will just use a particular URL. It will not use that all the that complete 4 or 5 lines of XML hard and fast rule which we saw in SOAP. So see, just a simple thing like REST web service. If I will compare, this is a simple URL which is used for accessing a REST web service. Like I've just given a example. So if I will compare a SOAP and a REST, so this how much, like 8 to 10 lines of codes in SOAP web service and just a 1 line of URL in RESTful web service. So nowadays modern web applications use REST, and we cannot conclude that which is best. It depends upon on your requirement and what usage you want to do with your web application, and depending upon your other different factors like time and improved efficiency. And if you want to have caching of the data, so you can go for REST. And if you don't want to strictly follow the rules, then you don't need to follow SOAP. SOAP is just like 20 years old, as I mentioned earlier also. So this is the difference between the SOAP and the REST. This is all about like SOAP, we have to write that much of code, and in REST just you have to use a particular URL to access that particular web service. So if I say what is the difference between SOAP versus REST, is like SOAP is a protocol and REST is not a protocol. SOAP can't use REST, but REST is an architecture side, so it can use SOAP. As I already mentioned, SOAP is a protocol and REST permits other data formats. Like SOAP uses only XML data format only, but REST permits other data formats such as plain text, HTML, XML, JSON, raw data format, and many other formats. SOAP standards are strictly followed. Like if you are using a web service which follows the SOAP type of web services, so it strictly follows the rules of the SOAP and you have to follow. But if you don't want to follow different too much standards and you want a flexibility, then you can use the REST type of web services, and you can enable communication between different web applications. So to expose business logic, SOAP uses interface. The whole code which I shown, like 8 to 10 lines, it is the interface of SOAP. But for REST, you just need a URL which you can use to access that particular web service. SOAP requires more bandwidth and resource, but REST requires less bandwidth and resource. So it is one of the plus point. You can go for REST type of web services. SOAP is less preferred than REST because SOAP is 20 years old, and now REST is more fast. REST improves efficiency. So REST is used by modern web applications to communicate between themselves. So there are different tools if you want to test web services. So there are different tools available in the market to test the web services. So there is one good and popular tool which name is SoapUI, and the second one is, which I will tell you, is Postman or Postman. There are different a couple of tools like Poster and etc. There are different tools which again they have different definitions, and there are different styles, and different test cases are also used to test that web services. So we'll be just knowing about the brief about the SOAP UI and Postman. So SOAP UI, it's the world's leading tool for web service testing. So if you want to test a particular web service, you can go for SOAP UI, and it's an open source cross-platform testing tool. So it enables like quick creation and execution of automated tests. You can make the list of cases, like if you want to make different types of cases for testing the working of your web service. Like in suppose you created a case and you want to see the result of that case, you can just make a list of cases and just you can run that web service for testing, and it will show you the results of different cases and their test. So apart from testing SOAP and REST web services, it is used for both testing the SOAP services and REST-based web services. It is also capable to test databases and messaging layers. It comes with an easy-to-use graphical interface which supports industry-leading technologies and standards to stimulate behavior and check the behavior of web services, like what web service is doing, how that web service is working, what are the different case results related to different cases, how it's handling the exceptions, how it's handling the errors. Next one is Postman or Postmaster. So it has an easy to use request builder. You can create and allows to write test cases and manage response data and response time for efficient testing and management of API test cases. Basically, it comes with pasting text feature for hassle-free test creation. Just you can copy a particular web service from a UTDI and you can paste and you can start testing that web service. So it also allows writing Boolean tests within Postman interface, and you can also customize it. You can also use the predefined scripts which are used to test web services. Let's move to next slide. It's securing. Now how you will keep your web services secured. You have created a web service and you have just published the web service, but there are chances, there are vulnerabilities, and your web services can be compromised, and due to the web services your web application can also be compromised. So these are the some measures you can implement to secure your web services. First one is apply defense in depth. Second, use least privilege. Third, exceptional handling. And fourth, message encryption. And the last one is message validation. Defense in depth is basically providing or implementing security at each and every layer, so that if one layer can compromise, it won't affect the other components of the web application. And there's some measures should be taken so that you cannot so that you can save your web application from being compromised. Second one, use least privilege. As the principle of least privilege is said, like minimum level of rights should be granted so that it cannot be misused for compromising or doing some malicious tasks with your web services or in web application. So you should be using least privileges which are needed to operate the web application by the users. Third one is exceptional handling. Suppose your web services or your web application is having some exceptions which are not being properly handled by the developer. So it is just releasing some or giving some information to the attacker, we can say that, or the user, which can be used for more information gathering, and it can be used to identify the different technologies or versions or components used by web applications. So it will be like a reconnaissance to the attacker or a malicious user, like it will throw an exception, and an exception is not handled properly, so it will lead to just like leaking of your data. The fourth one is message encryption. As the name suggests, encryption like refers to protecting a message by converting the contents to ciphertext using any of the cryptographic methods. So there are different cryptographic methods used to like protecting the message, so that it should be accessible to the only authorized person. And the last one is message validation. The message should be validated. Validated means verified, that the message input given as an input by the user should not contain any malicious content which can lead to compromise the web application. Includes like service filter, reject the different symbols, like in case of applications, the single quotes and other malicious inputs which can lead to some SQL injection or any other type of attack which can lead to compromise of the web service. So you should apply all these measures like defense in depth, use least privilege, exceptional handling, message encryption, message validation. You should not take untrusted user input, so that your web application works properly and your web services enables the proper communication between different web applications. Okay, that's it for the today's session on web services. We have learned about the what is a web service, how web services work, need characteristics of web services, architecture like components, the WSDL, the UDDI, types of web services which are SOAP, how SOAP works, how REST works, difference between SOAP and REST, like two tools to use to test web services, and securing web services.